There, we should be live now, hopefully. So, hopefully we're live. And if we are, then welcome to the Saturday MP show, episode number 99. I don't know, Omar, maybe we'll have to do something big for 100. I don't know what to do for that.
It's a big one.
Yeah. Being recorded live May 19th, 2026. I'm your host, Chris, and I'm joined by Omar. And today we're going to continue the ping client that we started last time for our last live broadcast. It was over 2 hours long. So if you made it through all that, wow, amazing. If not, you could get the TLDR is we're trying to write a ping application from scratch in C just because Omar wanted to learn more about low-level networking. And I'm trying to remember as much as I can about C, which has been a long time since I've done it. We had the app, we didn't know it, but at the time we actually had it working, but we ended the last video without it working. The problem was we weren't running the actual app we were making as a root user, as sudo. So it wasn't actually sending any packets, and we need to add better error handling is what I got. I had a little chat with like Claude after we were done recording, and it was like, yeah, you should actually read the error messages that come back from like when you send things. So that's something else we should probably add here, Omar, some error handling, just so
Yeah.
we can see what's going on there. But it actually does work. So we'll probably do a quick demo of that here in a second. And then hopefully the
Where were the
rest.
error messages coming from? Were they um from when we were looking at Wireshark or
No, we have
is
to
it
put this send command here that we were calling will return error messages. And I think with the same with the send to. Like what does send to return us?
oh yeah, okay.
Yeah, it returns us the size. Yeah, it returns the number sent or -1 for errors. So and then I think there's another way to get the error, and I think send, if we look at send here. Yeah, again, it'll tell us the number of bytes sent, so we should be able to tell right away, like if it's a -1, it didn't send any bytes. So that's a problem. So let's maybe add this here. What was it? Size T? I don't know, bytes sent equals this. And then we can go, oh yeah, so this is where we need to, yeah, we could write out the error messages and stuff.
Yeah.
So, okay, and then we were going to turn, that reminds me, we're going to return this autocomplete off because we're trying to learn as much as we can. So,
Yeah.
turn that part off. I do have Claude here. If we need to ask questions, I think last time we were using, oh, oops, not so. I meant to do this. Last time we were doing using Copilot, but we could switch
Yeah.
back to that if need to. But yeah, so this should tell us if this failed or not. So okay, let's just run this and see. If people, I guess if anyone's watching too, if you're watching this live, I don't think anyone is right now, but if someone does happen to be watching it, you can put questions or anything in the chat. I try to monitor it. You can send an email to ask@SaturdayMP.com. Do the whole like, subscribe thing. We would love it if you did that. But yeah, I think okay, that's all the housekeeping stuff. Let's get to the meat of this. Oh yeah, see, I added sudo to the makefile here, so it should hopefully just run it. Okay, so let's see. So let's start a new Wireshark thing. And it should make this, and then we can stop this. And then, yeah, we see it right here. So this is IPv4 one.
Yep.
And we know it's ours because this very last thing we sent is the IP address we want to send to, which is this. So we got the 8E, the FB, the 2E, and the 4E. And this is that Google IP address we're trying to ping.
Yeah.
So yeah, it looks like everything is working. Yeah, this we added this here. We sent out 20 bytes. Okay, so that's perfect. Great.
That's the new error message or the new error handling.
This part here.
Yeah, you just added that one.
Yeah,
Yeah.
yeah. I don't know. P error. This must be a print an error message. I don't remember that from my university days, but I thought printf had a. I think there was you could send it to different streams, like the Airstream or something like that. But maybe there was a PR. It's a long time ago. All right. Okay, so that's working. Hooray! Congrats. Okay, so what were we gonna do? The first thing we were gonna do is we were gonna look to make sure that this packet looked correct.
Right.
That we weren't. Yeah, I also asked. I guess just we talked about this beforehand, but I also like this. My notes. This is like a discussion with Claude. What can I clean up about the app? And it was like, oh yeah, your app's a real mess. There's a lot of things to clean up. But I think we talked about this before. We're just gonna ignore that for now. So I know if you're watching this is probably not the best way to write it. Maybe if we have time at the end of this video, or maybe we'll do it next time. We'll clean this up or something. Yeah, and then I was just asking about. I was having trouble. I think it was Claude or either Googling that told me like, oh yeah, you're not running it as admin when you run your app, and that was the problem. So because we could, if people watched the last video, we couldn't get anything to show up at the end of Wireshark. So or in Wireshark. So okay, but let's see what we got here. So it should end in these 4, and it does. And if we look down here, like this, if you remember, Wireshark will parse out our packet for us, and it's got the correct destination IP address there. It looks like it has the correct source IP.
Yeah.
Header checksum status. Oh, it's unverified. Okay, but there's our checksum. So the checksum was this kind of gross thing that Claude was like, there's a much easier way to calculate this. You don't have to do this gross thing that you're doing here. So maybe we'll try that later. Or sorry, the checksum is this gross thing here. And this is just actually creating the buffer.
Yeah.
It did spawn a good discussion last video about bit shifting.
Yeah.
See if you remember that. Yeah. I think that was probably the highlight. The 2 highlights from last video was bit shifting and binary math. Okay, but so I don't know 97BF. Did we should probably print out the checksum. Oh no, we printed out down here, but let's just do out of here. Okay, I don't know how would I, so I need to print f, the checksum is what, an integer? But I want that as hex.
Yeah, it's an integer. Yeah.
Yeah.
It's,
How do I print off the checksum for debugging as hex? Oh, yeah. See, I never remember all these fancy formatting ways. Okay. Printf has like a bazillion options. Okay, so print as lowercase hex 0 padded with 4 digits. Okay, well, lowercase is fine. That's what we want here. So let's just try running this. Oops, sorry. Okay, so that's what it says our checksum was. What was our checksum last time? Oh, interesting. It doesn't match.
no.
Why doesn't that match? Because what are we doing here?
It's one like the pointer and one the actual
What
value.
does H tons do? I forget. What does H tons do? Oh, right. It switches the. Do you know the Indian part? Do you know what that means?
Yeah, I was reading a bit
Big
about that.
Indian?
Big Indian and Little Indian.
Yeah.
Yeah,
So what that means is
that's
like
like a type thing, right?
yeah, like say do we had all this it's not really a type thing, it's more like math. So if you have like say we wanted to represent the number 10 or let's do 12, right?
Yeah,
To represent that in binary is oh no, I have to think about how to do this again.
just pick a smaller number.
So no, we need a couple. We need something slightly big here.
Oh,
So this
okay.
is 8, 4, right? 0, 0, right? Because this would be 1,
Yeah,
2, 4, 8. So this would be 12.
right.
So depending on the architecture of the underlying operating system, or I don't know if it's the operating system or the hardware. That I don't know. But sometimes you'll read like this number. The most significant digit is on the left.
Okay.
And I can't remember if that's Big Indian or Little Indian. We'll have to look. If it the other way to write it is 0011, right? So
Yeah,
you can think of it like this, like we're reading from right to left instead of this in this time. So
right.
yeah, so instead of writing 12,
Oh,
we read like Arabic, right? Like you read from right to
yeah,
left. Like so
yeah.
let's which one does it tell us down here? Which one is Big Indian and Little Indian? Uh, da, 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 da. Is okay. Now I have to. I guess we could just even just. We don't need the machine to do this. Big. It always sounds like Indian, like a native or like someone from India, but it's like it's
Yeah,
spelled with
like
uh,
Indian.
yeah,
Yeah,
which I never remember how to spell it, but uh, I think I spelled it correct. Yeah, and Indianissus.
interesting.
uh, sorry.
Interesting.
Okay, so
This,
little.
so this is a computer science concept. It's not a math concept.
Yeah, no, it has to do with the hardware, right?
Yeah.
So like there's the first. Yeah, so when you encode this 32-bit integer, which ones are the most significant bits that you should count? You should use. Which one's left? Oh, okay. So big Indian is thus closer to the way digits. Okay, so this is left to right. So big is left to right. Small is right to left.
Okay.
Yeah. So it just depends on. And then the other thing is like if you're transmitting, like if you're doing it on words or however you're doing it, like you might need to switch the like if you had a bunch of other ones here.
So you're saying
Or
like depending on the architecture, it'll read it a certain way. So
yeah,
yeah. Okay. Hmm.
yeah. So yeah, depending, it'll treat this as the most significant, the left, and sometimes it'll treat the right as the most significant.
I see.
So that's what this is doing. This is switching it. Um, yeah, it's big Indian on the wire, I guess. Okay, so what did it say here? Host to network short
Ah,
converts a
okay.
60-bit integer from host to byte order. So that okay. So I guess when we send it on the network is always big Indian. Yeah. So right, if it reads it backwards, you're going to get a weird number. So
Yeah,
okay. So that's what we're doing. Okay, so that's why we don't get the same number here. We get this checksum here, but we get a different number down here. Because we convert this is what we're doing. Okay. So I think that's correct. What did we get our...
that's why there's a discrepancy, you mean?
Yeah, that's why there's a discrepancy. So, okay. Well, I don't know. Let's assume that's right for now. We'll see.
Mm.
The protocol is 1, so that's great. That's this one here. Time to live, we put 40 hops, so that's good. Or sorry, 64 hops, which is good. And then what is this? Is all this fragmentation offset, which for whatever reason we put to 0, 0, 0, 0, 0. Yeah. These flags. This is just a unique number that we need to put in here. So as far as I can tell, this number doesn't matter too much. But we need, I think we just A, B, C, D, so we can see it nice and easy in here.
Right.
The total length of our IPv4 packet was 20. Is that bytes or bits? It's got to be bytes, 20 bytes. Differentiated services. So our type of service is 0. And then we said this is IPv version 4. That's what this part said here. So version 4. And then there's all this other stuff to the left here. This is part of that Ethernet and frame packet.
Right.
Sorry, there's the whole entire frame. There's the Ethernet part of the packet. And we just ignore this because the operating system puts this part for, like it adds this for us. So we don't need to do that. We don't do any of that. So, okay. So it looks like our packet, maybe the checksum's wrong, but let's just say it's correct for now. And let's just see what happens. Okay, so now the next thing we need to add is excuse me.
ICMP.
Yeah. So going off this example here that we did last time, so this is the part we've done, right? This, you can see my mouse, right, on your end there?
Yeah.
Yeah, so this is the IPv4 packet that we created here, right?
Right.
And then this is the part we need to create now. These kind of last little bits at the bottom here.
Okay.
So the type of message, kind of before we start chatting, we want to send type of 08 because if you look, I can make this bigger. Is the ICMP has various types of messages we can send. We want to send the echo, which is the ping. So that's number 8. And then there's a bunch of other ones here that we're not going to care about. We don't care about the code. That's probably used in some of these other messages. Maybe this code. We'll have to calculate another checksum. Yay! Identifier, I think, is just, again, a bunch of numbers. The header data, the identifier sequence can be used by the client to match the reply. Yeah, so like if you're sending a bunch of pings, you might want to put this as a different number every time. So if you sent like 4 pings, you know which, and then ideally the host will respond with the same identifier number. So you know which ones are which, I think is what this is used for. Oh, it's got a sequence too. I did find sequence. Oh, okay. So maybe, maybe they combine them. Like 1, 2, 3, 4 is just ping 1, ping 2, ping 3, ping 4.
To match the reply to the request.
Yeah. But it's kind of interesting here because they talk about how Linux uses a unique identifier for every ping process. And then the sequence number is increasing, where Windows uses a fixed identifier. And then the sequence, that's interesting. Sequence numbers only reset at boot time. Okay. So it must wrap eventually. And then I don't think we need any payload for this. for echo request. I'm sure payload is used for other data. So we could probably just use this. Well, if we use this, oh, interesting. Yeah, if we use, we could probably just steal this value right out of here, assuming we use our identifiers 1, 2, 3, 4, and then 0, 1. This is our checksum. Okay, so yeah, we could just try copying this right in there. Then we don't have to calculate. We don't have to calculate the checksum because we're gonna use 8. We're gonna use 0. Identifier, we can pick whatever. We might as well pick 1, 2, 3, 4, and 0, 0, 0, 1. And then let's see if this is works. And then if we want to, we can try and maybe calculate the checksum manually. Okay, let's try that. There's lots that can go wrong here. So actually, what I should do, let me.
When it added that, this might be a silly question, but why A there? Like there was like in the subtotal when it was adding the identifiers to the sequence number.
Sorry, give me 1 sec. Oh, let me commit this.
Yeah, sure.
I keep forgetting to do this, especially when I'm demoing and just chatting. I always forget to commit. Okay, sorry, what was your question there?
Yeah, so back in the manual, yeah. So it in the calculation it adds the identifier and the sequence number together, right?
Mm-hmm.
Shouldn't it be shouldn't the subtotal be 1, 2, 3, 5?
It's also
Like
adding
Y1.
this type of message code and checksum.
Oh.
So it's this plus this, which is 0, so it doesn't change anything, plus this, plus this. You're basically adding all these words, these 16 like 16-bit words together to get a number.
Okay, I see. I see.
Yeah, and then there's our checksum here. So
yeah.
Okay.
Cool.
So let's see if we can get that to work. So if we go here, I guess we'll just keep using our gross way of doing it. So this is the ICMP ping part. Sure. This is the IPv4 header. This is IPv4 checksum. I don't know if we need to change that after. Okay. Okay, so this is our payload. So if we're just going to copy I guess we could do, yeah, we're just going to copy this guy's example. Okay, so we can make this an unsigned char. How did we do it up here? Oh, we made each one a separate one. Okay, I guess we just stick with that. So ICMP type, which would be just 08, right? 08. unsigned char code ICMP code 00. The checksum, we'll have to figure that out. So unsigned char identifier. Dun, dun, dun. 1, 2, and then we're just gonna do 3, 4. Oh yeah, we were gonna cheat, and we were going to. We weren't gonna calculate the checksum. What did this fellow put, or this person put? So X E5, E5. Sorry, X E5, XCA. Okay. Semicolon. And then the sequence number is just 0001. Okay. So it's basically this. All right. So that's our payload. So this IP buffer needs to be 1, 2, 3, 4, 5, 6, 8. 8 bytes bigger. Okay. There's 28 bytes with IPv4 header, 20 bytes, and ICMP, which is 8 bytes. So, and then I guess we just do this goofy thing we did here.
That's what I was telling you, that you don't need to do all that.
Yeah, it's like, that's pretty gross. You should do it better. Don't be so dumb. So in this case, we just need the ICMP type, IP buffer equals ICMP code. This one I'll need to do the mem copy because it's more than one. This mem copy is kind of gross too. Like, plus offset. I don't want the destination IP in this. I want the ICMP checksum. And what is that value? How many bytes do we copy? Just 2. Okay. So that's offset is just 2. And then we do the same thing here and here for the sequence number and stuff. So ICMP identifier and ICMP sequence. All right, so theoretically, this should send out our ping. Oh, I guess we have to write our app to like listen for the response back. Let's just see what if Wireshark does anything with it. All right, let's see if this does anything. Oh, we got an error. Let's of unsigned expression line 90.
Always false. Huh?
Oh, so what is size of T? Unsigned long. Oh, um, comparison of unsigned expression in is always false.
Yeah, so it's always greater than 0, I guess. Greater than or equal to
Yeah,
0. Hmm.
yeah, because it's unsigned. How do okay, how do I force that to be signed?
Yeah, did you change that though? The
No, this is the error
you can't.
message that got added.
Yeah, that's what I mean, because it wasn't giving that error when you ran it before.
Yeah, it was. We were just ignoring it.
Oh, okay.
Which I got so excited that it was working. I
Okay.
didn't see that. So okay, we should probably fix this. So
Yeah.
just go away. Okay. Um, should fix this error. So oops. Did I actually paste it? Yeah, okay. The clear command was a local command. Oh, oops, I can't paste it clear. Sign. Yeah, how do you compare unsigned integers in C? Oh, right, because it's going to return us -1. Bytes sent.
Oh, and signed, yeah, signed can't be negative. That's the whole point.
Oh, yeah, we need this to be negative. So what did send to return, though? Oh, I forgot the S at the end. It's a SS size T, which I imagine means
Okay.
assigned size. Oh, okay. I think when I just first saw this, I was like, oh, it just returns a size T, but SS must be assigned. Yeah, so this is a long. If you look at the other one, it was unsigned. So
Unsigned, yeah. Yeah.
yeah,
So unsigned can't be negative by
yeah.
definition.
Okay. All right. So
Yeah.
that looks like. Uh, okay. So it actually did something. Let's fire up Wireshark here and see what it actually does. Continue without saving. Oh, they look. Look.
Huh.
Oh, I need to make this bigger. There we go. Look, it actually says. And we got a reply back.
Oh, yeah.
Yeah, look. It's kind of hard to see. I don't know if I can make this any bigger because this is coming from Linux. Can you see this?
You're just pointing at the code.
Oh, you can't see the Wireshark?
No. Is there like a pop-up window or something?
Yeah, it's not showing up.
No.
Oh, it seems. Okay, maybe I will need to.
Okay, no, I see it. Well, I mean, I'm seeing this window now.
Though this.
This at ETH 0.
Yeah. That's the Wireshark window. Yeah.
Yeah, now I see it. Yeah.
Oh, are you watching the stream, not the Zoom?
No, I'm watching the Zoom.
Oh, that's funny. There's a delay in the Zoom. Okay. Okay, but you can see the ETH0 window.
Yeah,
All right. So you can see that we got the ping, the initial one we sent up top here, and that we got a
yeah,
reply back. Oh,
yeah,
so that's awesome. Okay, so this is what we
yeah.
sent. And we can see down here we got the internet control message. I love that this one says unverified. This is probably wrong. And this checksum says correct. So we probably have a checksum error. Yeah, so there's the 8, right? We said this is a ping. Code 0 because we don't need it. The checksum was whatever. Checksum status good. Yeah, this one. Header checksum validation disabled. Yeah, our checksum must be wrong up there. Oh yeah, this is our identifier, just 1, 2, 3, 4, and then we just put a sequence of 1. Yeah, and then it shows it down here. So,
Nice.
and then you can see the response that we got here. Boop. So this is what was sent back to us from, like, our app didn't read this. Like basically our app runs and just dies, right? Like we sent
Yeah,
28 bytes and then that's it. We're dead. But Wireshark
right.
captured the response. And so let's see what's in its response here. So it said it's a version 4, of course, for IPv4. It didn't use any of these special things. Its length is 28 as well, which is the same as ours. So I guess it doesn't use any special payload. No identification, didn't use any flags. It has a long time to live, longer than what we sent. So that's fine. It says it's the ICMP protocol. Oh, the validation is disabled here too. Oh, okay, so maybe our checksum is right. This one's disabled as well. This is the address we sent it from, right? 142.251. Or sorry, this is Google's address right here,
That's Google's address. Yeah,
and it's sending it back to us, which is this internal Windows subsystem for Linux IP address here. And this is what it
yeah,
responded with. So it responded with a type 0. So if you remember here, the 0 is an echo reply. So it's this one here.
yeah.
So we sent an echo, and this is an echo reply it responded with. I guess the code isn't used here. Checksum's fine, whatever. The identifier is 1, 2, 3, 4 because that's what we sent, right?
Right.
And then the sequence is
Oh,
1.
yeah,
Yeah, so like if we sent a bunch of pings in a row, like when we did a sequence 1, 2, 3, 4, 1, 2, 3, we should get like it should
yeah.
get respond back 3 times with a 1, 2, 3. So that's how we can map that this was this ping response.
That's a different sequence number though than the one, or is that the one you put in?
No, the sequence number is 1.
Why are there two sequence numbers?
Because there's identification number and a sequence number. So if we go look here,
Yeah,
we
but it says
have
like sequence number BE and sequence number LE.
because there's two parts to it. Oh, I think because it's as BELE is at the. Oh yeah, I don't know why. Did ours have 2 parts? Oops. There we go.
I didn't think so.
Oh yeah, ours has 2 parts too for some reason.
Oh,
BELE. I don't know what that means. That's a good. We might have to look that up. Yeah, BELE, BELE. Oh, Big Indian, Little Indian is what that is.
oh, okay.
So you can see here, like you get the 12, 34, like, so this is Big Indian, like the 1, 2, 3, 4. Little Indian, so they actually just switch the bytes around for each byte, not for the whole word. So you see sorry, this
Yeah,
this 3,
yeah.
4 ends up here, and the 1, 2 ends up here. So it's not like they switch everything around. Oh, I guess my example wasn't that great that I showed you, but yeah, it's a little weird. And then same down here, right? They basically switched this from Big Indian to Little Indian.
Right.
So
Okay. they kind of do it by byte.
Yeah.
No, not by byte. I mean by like something.
But I guess I was wrong when I said Indianness. Okay, let's see here.
Hmm.
Oh, within a word data type or transmitted. Oh, okay. So, um, yeah, yeah, I guess here, I guess this shows us exactly what it's doing there. So 0D appears here, but it'll appear down here.
Hmm.
But the 0 and the D stay the same. So it's not like you switch the whole um, you switch the whole integer. So a word is like a byte, I think. Is that what they're talking about? A word is a byte. Bit width. I guess a word can mean several things.
Hmm.
Yeah. But anyway, yeah. So you got your 8-bit word, and so if you have a 16, or if you have this is a 32-bit integer, for each word, which of these words do you read first?
Hmm.
Yeah. Address is 8-bit long. It's called a byte. 32-bit words contains 4 bytes. Okay, a big Indian system stores the most significant byte of a word. So this is if this is a 32-bit word, and the smallest memory address and least significant byte in the largest. Okay. So it's not like, yeah, my example was wrong, where I just did the bytes themselves.
Yeah.
Yeah, you want to do the entire or sorry, when I did the bits, you want to do the bytes. So if you have like this one has 4 bytes, depends on which order you read the bytes in. I think. Did I explain
I
that
mean,
correctly?
that's not really what we saw happening in the ping, like with those two uh whatchamacallits, the sequence numbers, like the big Indian and the little Indian sequence number. Like it seemed like it um switched them in pairs kind of thing. So it's sort of like
Yeah, it switched
the
the
first.
byte. Yeah, so you group them together as a byte, so a byte is 2 hex values, and then it would put the 3 4 becomes the first byte it's going to read, and then the
Oh,
1
yeah,
2.
yeah, yeah, because this is text. Yeah, of
Yeah,
course. Yeah, 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 yeah.
and then
This
this
is
one
text.
down below, this 0 1 is going to be the first one it reads.
Right. I see what you mean
Zero
now.
zero,
Yeah,
yeah.
yeah.
So it's switching
Okay.
the
The
bytes
bytes.
around. Yeah.
Yeah. Okay.
So yeah, that was. I know it's working. I don't know.
Yeah.
Do we want to end this now? What time is it? I guess we should end it pretty soon. I gotta host the weekly dev chat here soon.
Yeah, that's all
Um,
right.
or is there something else we want to try? Okay, first I'm gonna do this though. ICMP message is working. Exclamation mark for that. Okay. Um, yeah. So this is working. Is there any one little thing you want to try or want me to fumble the explanation for? That's so cool.
That is pretty cool. So, I mean, just a recap here.
Okay. Yep.
Um, so what we did was we basically made a socket. Like so we that's the kind of the first thing we did was we established or like we wrote a socket
Hmm.
uh, in C. Um, and and then from there, um, we use that to develop the our like before we even got to the ping, we had to just sort of like um we had to yeah, so before we even made a ping request, which is what we were doing last time, what were we doing?
You mean last
Uh,
video?
yeah, yeah,
So the last video, all we accomplished, well, not all, but what we'd figured out is how to send an IPv4 header without any payload.
IPv4 header. Right, right.
So if we go here, so this is the IPv4 header, this part right here.
Yeah,
So we're saying it's version 4. I don't remember what this stands for. The length of all the things. Oh, we probably should update that. I don't know how that worked. And then we just need the source. Where are we sending it to? And where are we sending it? Or where are we sending it from? And where are we sending it to?
right.
So that's kind of
Yeah,
the basic header for an IPv4 packet. And then you can, of course, put other things in there. And the thing we decided to put in there was a ICMP packet.
yeah, yeah. So that's
Building
kind
a
of one of the
typo there.
simpler, just to send a packet over the
Yep.
wire.
Yeah. Like I picked that last time because I'm like, ping like looks like a really simple protocol to send.
Yeah,
There's not a lot, because other protocols will have payloads and stuff like that we probably need to deal with. Where I thought like a ping doesn't have a payload or anything. We just send a response and it sends us basically the same response back. So that seemed
right.
like a nice, easy test we could write to get it to work. So
Yeah, nice.
yeah, and
So
then
once we got the IP, once we were able to send over the IP header and we got a response. And that's what involved a lot of the kind of like um working with like binary sort of like like the additions that we were doing to be able to um basically translate that header into binary. So that and that because that's what we needed to do to get it um to the over the wire. Like it needs to be in binary.
yeah, there's there's no JSON or there's no field mapping or anything like that.
Yeah,
So if you remember, this is the IPv4, what a header should look like. So
yeah.
from bits 0 to 4 is the version,
Mhm, mhm.
and then from bits, 0 to 3, and then from bits 4 to 7 is I can't remember what the IHL stands for.
This is the
And
ICMP, not the header.
this is the header. This part here. This is
This is the header.
IPv4 header. This part.
Okay, because it says structure of ICMP echo request. Oh yeah, okay.
Yeah,
So it's just showing the header here. Yeah, yeah, yeah. Okay.
yeah.
Yeah,
So you have to put this part first, and then
yeah,
after you put this. And again, there's no like, when you send like a JSON packet or something these days, like
yeah,
you'd have the text like total length, and then you would have whatever here.
yeah.
And of course,
Key
all that
value.
gets translated into bytes like ASCII or not ASCII anymore. What the heck, Unicode or something like that. Like that's all going to be translated into Unicode. Um,
Yeah,
but for sending these packets, you don't deal with it to save space and optimize what you're sending. You're just going to say
You're
like,
not going to be sending that JSON.
yeah,
You don't want that processing to happen, basically.
yeah. No, you're just going to say like bits 0 to 3. Read those first 4 bits, and that's the version for the protocol we're using. Is it 4 or is it 6? Right? Like
Right,
there's
right.
IPv4, IPv6. There might be a 5. I have no idea, but um, and then whatever application's processing that, like if it sees a 4, then it knows the rest of the header is going to look like this. If it sees a
Okay.
6, I'm assuming the IPv6 header is going to be probably some of this will be the same, but your address fields are going to be different because they're those. It's probably going to be how many bytes do those things take up? Anyway, they're probably going to be like 8 or 16 bytes, not bits, but like bytes just for the address. So because they're much
Mm.
bigger, right? IPv6, and there's probably other headers and flags and stuff.
Yeah.
But yeah, so
And
that's
checksum is it's like a validation thing, like for um like checksum is some sort of calculation we use. Um,
yeah. I think in this case they use it for like error checking. So
right.
because things can get messed up over the wire, like it could be hardware problems or something like that. So we
Mm,
calculate this checksum using the IPv4 one. Well, we can use the ICMP checksum is this, right?
mm,
So theoretically, what the receiver should do on the other end is when they receive this packet, is they should also calculate this checksum using this formula. And
right.
if they don't get the same value that was sent, then something went wrong in the transmission. It was either tampered with or there was a hardware error or something like that. So that's like an
Right.
error, like it's like an error handling method.
Right. Yeah. Yeah.
It's kind of,
And that's and that hence something gets sent, like that gets sent back in the packet that gets sent back.
yeah, there's
Um,
probably like we got an error. Let's see. Um, that was extended echo. We could do an even bigger one. I don't see an error one. I don't know. Let's take a look. ICMP type numbers. Because I would assume that, like, theoretically, the receiver, maybe for ping, they don't care. But, like, for IPv4, like, if the checksum doesn't match, you might either just drop that packet or you might send a response back saying, like, hey, you sent a packet that doesn't match. Try again. Like, something went wrong with
right.
it.
Right.
Um, uh,
Would it
uh,
because there's so many packets being sent at any given time that it wouldn't be like practical to respond to each one if there's a problem with each, with any given one, or there's kind of
uh,
like a
for ping, I don't think it matters. Like, nobody cares.
hmm,
I'm trying to remember for TCP/IP. Oh man, you're really. I probably have to do some digging, so don't take this as the truth. But I don't know where this happens on the network stack, but there is the fact that packets could arrive. So say we're sending a longer message, right? And it got broken up into like 5 separate packets. Those
yeah,
packets might not arrive in order at the other end. So if you sent
yeah,
packet 1, 2, 3, 4, 5, I guess we can, let's go. Uh, we have something to look at here. So if you send packet 1, 2, 3, 4, 5, those are the 4 packets you sent in that order. They might arrive like 1, 3, 2, 5, 4, 5, or something like this, right?
right.
And then so it's up to the receiver to take those packets and reassemble them into the correct order. And then the other thing that might happen is like you might get these packets, right? You might get 1, 3, 4, 5, and in that case,
Yeah.
you'll get a bunch of packets, and then I hope packets is the correct term. Again, people are probably yelling at the screen. Then it's up to the receiver to return around and be like, "Hey, you never sent me 2." Like when you originally
Yeah.
sent a message, I'm going to send 5 packets, and here
Yeah.
and it said 5, and then the receiver only got 4 of those packets. It's going to be like, "Oh, I'm missing one. I'm missing number 2. Send me 2 again." And then
Yeah.
hopefully it'll send you 2 like later. So that's not part of any of the ping. I think that's part of is that part of TCP or is that part of IP? I don't know. Let me look at my big fat book here.
Mm.
So, or maybe I'll have to Google search that. Maybe I'll do that instead. That'll be a little more interesting. But yeah, that's so some of those higher level protocols, which I think TCP/IP does. Excuse me. We'll do something like that.
Yeah. Okay. Super interesting.
Yeah. Excuse me. Yeah, and I got
Well,
this.
thank you.
Yeah. No problem. Yeah, I guess we should wrap this up. Excuse me. No, that was a good. I don't know. That was a good question you asked, and I think this is fun videos to record. I learned a lot too.
Definitely.
So yeah, I don't know if we
Yeah,
can.
I mean, I could do this stuff. I could do a lot of this. You know, I definitely, I would not get tired of this.
Oh, this low level stuff.
Yeah, yeah. I mean,
Oh, okay.
it's interesting to me.
Oh, okay. Well, maybe we'll have to think of another low level problem or something. Maybe we'll see. We got a couple people in our community too that are much smarter. They know more about C and low level stuff. Maybe we could see if we can get one of them on the show too to answer some of our questions. Okay, yeah, Omar, we'll have to chat offline about what we want to record because we got the 100th episode coming up too.
Yeah, it's true.
Yeah, maybe I don't know what we can do for that. We'll have to think of something cool. But yeah, no, this is great. So yeah, thanks, Omar. Thanks for the suggestion. This was a lot of fun. I'll see if I'll try and put this for people watching. I'll try and put this this gross, ugly code online so people can view it and run it and play around with it. And maybe I'll clean it up too if I got time. I'm pretty busy this week, unfortunately. And yeah, if you made it all this way, again, well, it's not nearly as long as last time. Thanks for watching. If you have any questions, comments, or anything like that, you can leave them in the comments below if you're watching this on YouTube, or send an email to ask@SaturdayMP.com. Like and subscribe and everything. Make Omar and myself feel better. And then again, if you liked it, liking and subscribing just puts boosts like this show up in the algorithm so other people can find it as well. So, but yeah, thanks again, Omar. This was so much fun. And we'll catch everyone hopefully next week. Hopefully we'll be back to Monday because Monday was a holiday this week. So next week we should be back on our regular Monday schedule. Yeah, thanks again, Omar.
Thank you.
Yeah,
My
have a good
pleasure.
one. Have a good one, everyone.